Good day, grade 10 learners. Welcome to a new session of Valenzuela Live in Mathematics 10. I am Mrs. Beller C. Flaviano from Gente Burcia de Leon National High School. And as Frank Herbert said, one learns from books and example. Only that certain things can be done. Actual learning requires that you do those things. So I hope you have your pen and paper with you so that we can solve and enjoy learning today's lesson. We are now on the fourth week of the third quarter, which is about differentiating permutation from combination of n objects taken R at a time. At the end of this session, you are expected to differentiate permutation from combination and solve permutation or combination of n taken R at a time. Before we jump in our lesson, let's play a game first. This one is entitled, What's Your Order? You will be given 5 seconds to think and determine if the situation requires order or not. Then click the reaction that corresponds to your answer. Are you ready? Let's start! Here's the first situation. Opening a combination lock. Is it like, order matters, or hard, order does not matter? You have 5 seconds, go. Alright, time is up. The correct answer is, order matters. If you have a combination lock or you have used one before, you will know that you can open it if the numbers are not in proper order. So let's have the next one. Here's the next situation. Assigning seats in a queue. Is it like, order matters, or hard, order does not matter? You have 5 seconds, go. Time is up. The correct answer is, order matters. In lining a queue, it may be sometimes first come first serve or by appointment, but either way, order still matters. Let's have the next one. Selecting balls from a box. Is it like, order matters, or hard, order does not matter? You have 5 seconds, go. Okay, time is up. The correct answer is, order does not matter. Okay, let's have the next one. Forming triangles from set of points with no 3 points are collinear. Is it like, order matters, or hard, order does not matter? You have 5 seconds, go. Alright, time is up. The correct answer is, order does not matter. In forming a triangle from set of non-collinear points, it doesn't matter what vertices you started to connect as long as you can draw a triangle. Okay? Now let's talk about our topic, which is about permutation and combination. Take note that permutation and combination are both selections made from a group, and that is their similarity. On the other hand, their difference involves order, because in permutation, order matters, while in combination, order does not matter. Now let's look back at our previous game. Here we have determined that order matters in opening a combination lock and assigning seats in a queue, while order does not matter in selecting balls from a box and forming triangles from set of points. These situations illustrate permutation and combination. In opening a combination lock and assigning seats in a queue, permutation is implied, while selecting balls from a box and forming triangles from set of points, combination is implied. Let's recall formulas for selecting n objects taken R at a time. For permutation of n taken R, we have n taken R equals n factorial all over n minus R factorial. for combination of n taken r, we have n choose r equals n factorial over n minus r factorial times r factorial. Remember that in both formulas, r is greater than or equal to 0 but less than or equal to n. Let's have another round of our game. This time, you will have to determine if the problem or situation implies permutation or combination. You will be given again 5 seconds to think, then click the reaction that corresponds to your answer. Are you ready? Let's start. If the available toppings are cheese, pepperoni, mushroom, pineapple, and olives, how many pizza variants are possible using 3 different toppings? Thus, the situation implies permutation or combination. You have 5 seconds, go! Okay, time is up. The correct answer is combination. Okay, let's answer this problem. This problem implies combination. To solve this, we will use the formula for combination of n taken r, and that is equal to n factorial over n minus r factorial times r factorial, where r is greater than or equal to 0 but less than or equal to n. N is the total objects, while r is the objects selected at a time. In this problem, the objects are the pizza toppings. To determine n, let us count the toppings. We have cheese, that's 1, pepperoni, that's 2, mushroom, that's 3, pineapple, that's 4, and olives, that's 5. So we have n equals 5. On the other hand, 3 different toppings are selected at a time. So we have r equals 3. Let's proceed. Substitute the value of n and r to the formula, and we will have 5 choose 3 equals 5 factorial over 5 minus 3 factorial times 3 factorial. Next is we are going to simplify the grouping symbol. That is 5 minus 3. 5 minus 3 is equal to 2, and our equation will be 5 choose 3 equals 5 factorial over 2 factorial times 3 factorial. Next, we will expand up to 3 factorial in the numerator so that we can divide out 3 factorial in the denominator. Now we have 5 choose 3 equals 5 times 4 times 3 factorial over 2 times 1 times 3 factorial. Okay? Then divide out 3 factorial. And also, of course, we can divide 4 by 2. And that is 2 for the numerator. Finally, multiply the remaining factors, which are 5 and 2. So 5 times 2 is 10. We will have 5 choose 3 equals 10. Therefore, the answer is there are 10 possible pizza variants. Okay? Let's have our next problem. How many different 4-digit ATM PIN codes can be made if digits cannot repeat? Thus, the situation implies permutation or combination. You have 5 seconds, go! Alright, time is up. The correct answer is permutation. Let's answer this problem. Okay, now this problem implies permutation. To solve this, we will use the formula for permutation of n taken r, and that is equal to n factorial over n minus r factorial, where r is greater than or equal to 0, but less than or equal to n. In this problem, the objects or the total objects selected are the numbers on the numpad, while our r here will be the digits selected at the time. So let us determine our n, okay? The numbers on the numpad are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So all in all, we have 10 digits. For the object selected at the time, we have 4 digits. So R is equal to 4. Let's proceed. Substitute the value of N and R to the formula. We will have 10 taken 4, or permutation of 10 taken 4. That is equal to 10 factorial over 10 minus 4 factorial. Next, simplify the grouping symbol. That is 10 minus 4. That is equal to 6. And our equation will be 10 taken 4 equals 10 factorial over 6 factorial. Next, we will expand this up to 6 factorial in the numerator so that we can divide out 6 factorial in the denominator. Now we have 10 taken 4 equals 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. Then, divide out 6 factorial. Okay? Finally, multiply the remaining factors, which are 10 times 9 times 8 times 7. And we will have 5,040. Therefore, the answer is 5,040 possible ATM PIN codes. Okay? Let's have the next one. In how many ways can 7 contestants win first, second, and third place? Thus, the situation implies permutation or combination. You have 5 seconds, go. The correct answer is permutation. Okay, let's answer this problem. This implies permutation. Okay, to solve this, we will use permutation of n taken r equals n factorial over n minus r factorial, where r is greater than or equal to 0, but less than or equal to n. Remember that n is the total objects, while r are the objects selected at a time. Okay? In this problem, the objects are the contestants. So we have n equals 7. And for our r, those are the awards that can be won by the 7 participants or contestants. Therefore, we have first, so that is 1, second, 2, and then third, 3. R is equal to 3. Okay? Let's proceed. Substitute the value of n and r to the formula. We will have permutation of 7 taken 3. That is equal to 7 factorial over 7 minus 3 factorial. Simplify the grouping symbol. That is 7 minus 3. It is equal to 4, so we will have 7 taken 3 equals 7 factorial over 4 factorial. Of course, we will expand our equation. So 7 factorial will be expanded up to 4 factorial to divide out the 4 factorial on the denominator. We will have 7 times 6 times 5 times 4 factorial over 4 factorial. Now we can divide out 4 factorial. Okay? Next is to multiply the remaining factors, which are 7 times 6 times 5. And the answer is 210. Therefore, the answer is 210 ways. Let's have the next problem. How many 3-person committees can be selected from a group of 8 individuals? Thus, the situation implies permutation or combination. You have 5 seconds, go. The correct answer is combination. Let's answer this problem. Now, this problem implies combination. Of course, to solve this, we will use the N choose R formula. That is n factorial over n minus r factorial times r factorial. Remember that r is greater than or equal to 0, but less than or equal to n. Okay? N, of course, is the total objects, while R are the objects selected at a time. In this problem, the objects are the 8 individuals, so we have N equals 8. On the other hand, 3 of them will be selected at a time to form a committee. So we have R equals 3. Let's proceed. Substitute the value of N and R to the formula. We will have 8 choose 3 equals 8 factorial over 8 minus 3 factorial times 3 factorial. Don't forget to simplify the grouping symbol. That is 8 minus 3. Now we will have 8 choose 3 equals 8 factorial over 5 factorial times 3 factorial. Of course, we are going to expand it. Expand the numerator up to 5 factorial. And that is because we have to divide out the 5 factorial on the denominator. Now we will have 8 times 7 times 6 times 5 factorial on the numerator. While on the denominator, we have 5 factorial times 3 times 2 times 1. And that's the expansion for the 3 factorial, okay? Then divide out 5 factorial. We can also divide 6 from the factors of 2 and 3 on the denominator. Now, finally, multiply the remaining factors, which are 7 and 8. And we will have 56. Therefore, there are 56 possible committees. Now, this time, it's your turn. Grab your pen and paper and try answering the following problems. You will be given 30 seconds to do so, okay? Are you ready? Let's start. For the first problem, Elijah has 8 colored pencils that are all unique. He wants to pick 4 colored pencils from his collection and give them to his younger brother. How many ways can he do this? You have 30 seconds. Go. Alright, time's up. And the answer is, he can do it in 70 ways. This problem implies combination because order does not matter in selecting colored pencils. Do you have the same answer? That's great. Let's have another one. Abel wants to take the science, technology, engineering, and mathematics strand that is also known as STEM in senior high. If there are 14 schools in Valenzuela offering STEM strands, how many ways can he select his first and second choice of school? You have 30 seconds. Go. Okay, time is up. He can do it in 182 ways. This problem implies permutation because order matters in selecting for the first and the second choice. Do you have the same answer? Very good. Now remember this. One important thing to consider in solving the number of ways in selecting n objects taken are at a time is the order. If order matters, then that's permutation. If order does not matter, then that is combination. Here's the formula for permutation. N taken r at a time is equal to n factorial over n minus r factorial. While combination formula is n choose r equals n factorial over n minus r factorial times r factorial. Remember that r is greater than or equal to 0 but less than or equal to n. Alright, that's it. For your homework, answer the following word problems flashed on the screen. Okay? Let us now talk about the frequently asked questions regarding our topic. Are there any keywords that we can use to identify if a problem implies permutation or combination? The answer to that is we can keep an eye on the words like select or choose for combination and arrangements, ordered ways, and unique for permutation. But generally speaking, most of the time, you get a question that implicitly uses the application of permutation and combination. If keywords are not given, then visualize the scenario in the question. Then think in terms of combination and permutation. If order matters, that's permutation. If order does not matter, then that's combination. Let's have the next. Is there an instance where the number of combination is greater than the number of permutations? Now, the answer to that is permutation is always greater than combination because in combination, order doesn't matter. That is why, to get combination, we further divide the arrangement where order matters to the arrangement taken at a time. In short, combination is equal to permutation divided by r factorial. Now, remember this. Life is a matter of choices, and every choice you make makes you. And that is from John Maxwell. And that's it for today. Thank you, grade 10 learners, for listening and actively participating in our activities. God bless us all. Bye.